We're here in Prudhoe Bay, Alaska, site of the largest oil field in North America. For the next week, I'll be traveling with a team of scientists studying changes underneath the Arctic tundra that are contributing to global warming.
Beneath the active layer of tundra, the part that thaws every spring and summer, is a deeper layer that doesn't. It's called permafrost, and over thousands of years, it's locked up more than 1.4 trillion tons of carbon, about twice as much as what's in the atmosphere. But as humans continue to burn fossil fuels, warming the planet, permafrost is starting to thaw, potentially turning into a source of emissions rather than a sink. So what else is causing that deeply frozen layer to thaw, and how much of those harmful greenhouse gases are escaping? That's what researchers are here to understand.
This is my first day in the field with the teams. The weather looks great, and today we're going to be collecting samples along the coast of the Beaufort Sea.
Climate change is raising sea levels and causing more severe storms, which means more salt water washing over tundra. The scientists I'm following here have one big question. Does tundra emit more CO2 if it's inundated with seawater?
If it is, that could have significant impacts on the rate of warming, because when you add salt to a substance, it lowers the freezing point.
The interactions between saltwater, permafrost, vegetation, and the release of greenhouse gases into the atmosphere are complex and not well understood. But in coastal areas, the team believes they could be significant.
Julia Guimond and Alina Spears are hydrologists, and they are behind me taking measurements to paint a picture of the way that salt water makes its way around the tundra and also down towards the permafrost.
The groundwater samples collected show where that water is penetrating and how the salt, as well as other chemical changes, could affect how much carbon is finding its way to the surface. That's where Jacqueline Hung comes in. She studies the exchange of greenhouse gases between the land surface and the atmosphere. When plants photosynthesize, they take carbon dioxide out of the air. But when plants and soils respire, they release it, along with methane, another potent greenhouse gas.
Gorgeous day. We parked on the oil pad, had a calm boat ride along the shore, and Jackie is behind me setting up her equipment on the tundra.
Salt and other chemicals in the soil affect which microbes play the biggest role decomposing all that organic material that's unlocked when permafrost thaws. Jacqueline's field studies will measure the mix of greenhouse gases that the tundra breathes out to try to get a picture of the net carbon balance in this landscape. After a long week of painstaking work in the field, the samples are packed up and sent for months of analysis back home. So much research is needed, and every second counts.